Lesson, Covariance and Correlation, Pearson and Spearman. Welcome. Today we will learn how variables relate to each other. We will explore covariance and two ways to measure correlation. You do not need advanced math to get started. Let us begin. Running the cell now. What are covariance and correlation? Covariance shows if two variables move together or in opposite directions. Correlation tells how strong and in what direction that relationship is. We measure relationships using numbers from data. Let us see some simple examples. Running the cell now. First, let us set things up. We stop warnings so they will not distract us. We import tools for working with data, calculations, and plotting. We bring in pandas, which is great for tables. We bring in Seaborn for easy access to built-in datasets. We import matplotlib for charts. We will use the miles per gallon dataset with data about cars. We load the data. We remove rows missing any of the key columns, miles per gallon, horsepower, or weight. We print out the shape so we see the size. We print a quick preview of our data. Now we can see the first few rows of the dataset. Running the cell now. Try exploring other datasets with sns.load_dataset. Which ones look interesting? Visual exploration. A scatterplot is a great way to see relationships between variables. Let us plot horsepower versus miles per gallon, miles per gallon. What do you notice? Running the cell now. Let us draw a scatterplot. Here, we set the size of our chart. We plot horsepower on the x-axis and do miles per gallon on the y-axis. We add a clear title. We label the x-axis to show horsepower. We label the y-axis to show fuel efficiency. We show the finished plot. Running the cell now. Sketch your own simple scatterplot using two columns in a different dataset. Intuitive idea. If two variables move together, the points go in a line. High horsepower, low miles per gallon? That is a negative relationship. High horsepower, high miles per gallon? That would be positive. Now let us see this with numbers. Running the cell now. Let us measure how two variables move together with covariance. We will use NumPy's cov function to calculate covariance between horsepower and miles per gallon. np.cov returns a matrix, so we pick the value that represents how they move together. The result tells us, if positive, they increase together. If negative, one goes up as the other goes down. Running the cell now. Change the columns for a new pair, like weight and miles per gallon. What sign do you get? What does the number mean? Covariance is hard to compare because it depends on the units of data. Large values can mean little if scales are different. That is why we use correlation. Correlation puts everything on the same scale. Running the cell now. Now, let us measure the strength and direction of the relationship with the Pearson correlation. Here we use pandas core function for the Pearson correlation. A value near 1 means a strong positive relation, near -1 means strong negative, and close to 0 means little connection. We print the result so you can see the relationship as a single easy-to-read number. Running the cell now. Try core with two other numeric columns. Do you see any strong positive or negative numbers? Pearson looks at straight-line relationships. Let us try Spearman correlation, which works even when the relationship is not a line. We calculate the Spearman correlation. It checks whether high values in one variable tend to match high or low values in another, even if the jump between them is not even. We use the method equals Spearman option in core. This kind of correlation works better when the pattern is curved or not exactly a line. Running the cell now. Test this with columns where one might not increase evenly with the other. How does Spearman compare to Pearson? Quick reference table. Name measures shape required use case. Covariance movement, raw, any first look, math. Pearson linear relation line shaped most numeric relationships. Spearman rank, monotonic, any curve rankings, nonlinear trends. Tip, monotonic means always up or always down, not zigzaggy. Running the cell now. Often, you want to see all pairwise correlations at once. Let us make a heat map. We calculate correlations between every pair of numeric columns. We make a nice color plot called a heat map. We set the plot size so numbers are clear. We use Seaborn's heat map to fill out the values and colors. We add a title to make it clear. Now we display it. Running the cell now. Pick a spot in the heat map. Which columns are most tightly linked? Sometimes, variables are ordered or in groups. Spearman can help even when they are not pure numbers. We turn the origin string into a category number for analysis. We calculate the Spearman correlation to see if cars from certain places tend to have higher or lower miles per gallon. We check if there is a pattern based on origin and efficiency. We print the result. Running the cell now. Try making another category column and checking its correlation. Let us see the trend with a fitted line, which shows how well data fits a straight line. We use Seaborn's lmplot to create a scatterplot with a line showing the trend between horsepower and miles per gallon. We keep the scatter points a little see-through, so the line stands out. We add a title to clarify what is shown. We label the x-axis for horsepower. We label the y-axis for miles per gallon. Now you can see if it is a straight line pattern or not. Running the cell now. Try plotting different variable pairs to see different relationships. Real data is messy. Let us see how adding a big outlier changes the correlation. We make a copy of the data so we do not affect the original. We add a new point with huge horsepower but very low miles per gallon, making it stand far outside the normal range. We recalculate the Pearson correlation with this outlier included. We print out the new value to compare. Running the cell now. Try different extreme outliers and see how much the number changes. Summary: when to use each. Use covariance to describe same direction movement, but numbers are hard to compare. Use Pearson for line-style relationships without dramatic outliers. Use Spearman for rankings, or if not sure the relationship is straight. If there are wild values or categories, pick Spearman. Next, let us practice. Running the cell now. Let us practice by picking two columns and comparing them. We offer a chance for you to enter the names of two columns. First, you type one column to compare. Next, you type another column. If both are valid, we print covariance, Pearson, and Spearman correlations. We help you see all three numbers side by side. We print out the Pearson correlation. We print out the Spearman correlation. If the columns are not found, we let you know. This way, you can try out relationships you are curious about. Running the cell now. Good job. Now, Try a way to and miles per gallon for invent your own comparisons. Want more? Hit like and subscribe to see all our future lessons. Troubleshooting tips. Blank or missing values give errors. Use dropner to fix before running correlation. Use the exact column names, try df.columns to check them. If you get a value near 0, variables might not be related. Large outliers can break Pearson. Try Spearman instead. You are getting better at finding relationships. Running the cell now. Here is a shortcut to find which columns are most linked to miles per gallon. We list all columns correlated with miles per gallon, sorted from lowest to highest. We drop miles per gallon itself since it would just be 1. First, we print the title. Then we print the values for a quick scan. Running the cell now. Which variable explains the most about miles per gallon? Which one is least related? You can ask new questions by looking at small groups of data. We create a subset of the data for cars from Japan. If there are cars, we compare horsepower and miles per gallon using Pearson. We see the values only for Japanese cars. We also print the Spearman value for a more robust look. If the group is empty, we let you know. This checks if that country has enough information to explore. Running the cell now. Test out a different country for practice. Recap. You have learned. Covariance shows do they move together. Pearson, best for lines, sensitive to big outliers. Spearman, best for ranks and nonlinear trends, handles wild values better. Try this lesson with your own data. Thanks for learning with us. Running the cell now. Curious for more? Post your own findings or questions in the comments below. Subscribe to the channel for more beginner-friendly statistics lessons. See you in the next video. Running the cell now.